All right, well, welcome everyone. Super excited to continue our conversation that we've been having over the years about the shift from traditional construction to panelized, manufactured, and modular type housing. There are so many benefits to increasing the sustainability of our homes and solving our housing crisis as we shift from more off of more on-site construction to offsite construction in many different ways and aspects. And so I'm always just excited to continue that conversation and enter into this to see what are the challenges, what are the opportunities to ultimately achieve these goals and move towards this way of building things. Um, Before we get started, I did want to say do our membership spotlight and say a big congrats to our member Gerard. He won a copy during a drawing the other month of a book for the webinar Feel Good Homes. He got a free copy of the author's book who was associated with the webinar. And by being a GHI member, you can win these books when we have authors on to give them away. So, this is who GHI members are. This is what GHI members do. And so can you. Learn more over at greenhomeinstitute.org/become a member. And then also, before we jump into it, a huge thanks to our top tier sponsor, Rheem, who is making decarbonized water heating for new homes and existing homes using heat pump technology. These heat pump water heaters are also typically approved for the Inflation Reduction Act homes rebates in the States or the tax credits while they last. So make sure to pick one up. And they have their 120-volt tech system as well that can easily be plug and play, swap right out with a gas system, and go from there. So check them out over at greenhomeinstitute.org/ream, HPWH. All right, this session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little, and I am the education manager here at the Green Home Institute. As always, like all of our courses, this one is approved for multiple continuing education units, including two of the pillars of green energy and materials in our certified green home professional designation. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. Check for that 5-digit passive house code if you need it at the end. It'll be in your certificate and the email as long as you're here for the entire CU approved hour. So with that, everyone, welcome to The Future is Panelized, building better with precision and performance and efficiency in mind. I am super excited for today's speaker here, Will Lentley with Saint-Gobain. Will, I'm glad to have you, and please go ahead and take it away.
So my name is Will. I am a R&D group leader and building scientist with Certainteed. Certainteed is a North American building products manufacturer. So you may know us from our roofing, our siding, insulation, maybe gypsum, waterproofing, all that fun kind of stuff. We make lots of different building products in this region. But my focus is actually on offsite construction. So I have been the technical lead developing a closed panel system. We'll talk about what that means. Honestly, I'm just going to jump right into it. We can hopefully make up some time. So classic copyright. This is copyright certainty. You guys have copies of the slides. If you have any questions or anything, just don't misrepresent the data or claim it's yours. That's all I ask. What we'll talk about for learning objectives. So we'll be understanding how advanced panelized construction solves industry challenges and improves on traditional construction models. We'll comprehend the construction, performance, and design benefits of advanced panelized floor structures, wall panels, and roof panels. I'll introduce you to assembly design, considering air, heat, water, and vapor management. That's like my building science training snuck into this. And then we'll understand the testing and research that goes into a panelized system. So how will we do that, right? I'll talk first about what is offsite construction, what's the difference between panelized and modular, talk about industry challenges, the construction process and how you work with a panelized manufacturer. We'll do that deep dive into building science. Specifically, we'll focus on a wall assembly, but it generally applies to all different types of assemblies. And we'll get into some case studies, testing, research, and development that we did to develop our system. And finally, at the end, there's key takeaways. So as an introduction, Brett, hopefully you can help me. I'm very curious of the people in the audience. What is the first thing that you think of when I say the word prefab? Does manufactured housing immediately come in your mind? Maybe you think of modular construction. I'm curious. And if nothing comes to mind, that's also okay. Maybe everything comes to mind. I'm just curious what you all think. There might be one on here that you might be a little confused about, but I promise I'll talk about it. And hopefully everybody I saw the poll pop up. Hopefully it's working for everybody and you can just answer there and we'll go through it.
Yeah, we'll give everyone 5, 4, 3, 2, 1.
Okay, so we're seeing a lot of all the aboves, which is good, and a pretty even split between modular and manufactured. So and actually a few people, 4 people said trusses. So traditionally, people don't think of trusses when they're thinking of prefab. And when we get into the definitions, we'll talk about how it doesn't really apply. But the reason why I bring it up is because back in the day, let's say when truss plates were developed in the 50s and when trusses started becoming more common in the 60s and into the 70s, I'm sure a lot of people thought trusses were offsite construction. They were traditionally building things, building rafters on site, building roofs. But now trusses are well adopted. They're used by a majority of builders, and they have fundamentally altered the way that we build our roofs, right? And how we build our houses and how they look aesthetically, right? So I want you to have that in the back of your mind as we are moving through this presentation about how thinking about prefab, thinking about offsite construction could influence the way we build in the future. One aspect that we did bring up was a lot of people said, hey, I think of manufactured homes. I think that's a very common conception that people have, is that manufactured housing is the first thing that comes to mind. And we'll talk about it and how it's defined in some of these definitions going forward. So I'm going to drop the trusses for now, but I just want to ground ourselves in what are we talking about today, and we can move forward. So the ICC and the MBI, Modular Building Institute, have definitions for what they mean when they say offsite construction or open construction or industrialized housing. And I want to walk through these with you. Don't worry, there's not going to be a test, but I hope this gives some context for you. So industrialized housing is when a residential structure is built at the location other than the permanent site. But there's a key caveat, that is, it is installed on a permanent foundation system. So if we go back to our definitions before, if we're talking about industrialized housing as the ICC defines it, manufactured housing would not be considered because it doesn't have a permanent foundation. So we're not going to be talking about it today. The next is the difference between offsite construction and then into open construction. So offsite construction is when wholly or a substantial part is fabricated or assembled in manufacturing plants, but all the parts or processes cannot be inspected at the installation site. So that might be that maybe gypsum is installed or there's a house wrap on it. You can't see all the nails. Whereas open construction, all the portions can be readily inspected at the building site without disassembly, damage, or destruction. You're not ripping apart things or taking things out. You can just see the nailing patterns, for example, which is something that an inspector might be concerned about. So when we look at the different types of offsite construction, open panel, which traditionally is framing and sheathing, would be considered open construction because you could still see all that nailing pattern, you can see the studs, you can see everything. Whereas when we start getting into closed panel or modular, we're entering the offsite construction space, and you might hear the words closed, enhanced, advanced. These are systems where finishes start coming into play, where layers are getting covered, and now the inspection process gets a little bit trickier. So now let's talk modular versus panelized, or modules versus panels. So a module by the ICC is considered a three-dimensional section that is transported in a single section or unit independent of other sections. So that's when you would see what I would call like 3D mods going down the road. They have full structure. They're not just two-dimensional volumes. Whereas a panelized, which is the space that I primarily work in, is where the walls, floors, or roof components are constructed at a location other than the building site. But the assembly into a three-dimensional volume or into a home happens on the job site. So to put it another way, open panel and closed panel would be panelized systems, might be obvious on the slide, right? And a module would be when we're talking about modular construction, where you're seeing boxes going down the road. So if we put it all together, what we're going to be talking about today primarily are closed panel systems, where they are enhanced or they have more features to them, where maybe the insulation comes with them or the siding, which would be industrialized housing that is offsite construction that is part of a panelized system. I know this is confusing. I know there's a lot here. You all have the slides, so, and if you need anything or you have questions, please, you can always reach out to me afterwards as well. But we're mostly going to focus on the middle, but I think there's a space in the industry for all these types of construction. I think they all have uses, and I think they're all very important for construction going forward. So there you go, closed panel, offsite, and panelized. So challenges in the industry and how panelized helps. So a few industry challenges. I'm sure many of you have dealt with these things, such as labor. It can be a very significant challenge to find labor for building homes. Schedule delays, maybe you couldn't get materials in time, or because of labor challenges, you had delays. There's also warranty risks. If you're combining materials from lots of different manufacturers, how do you know who was at fault when something happens? Was there something wrong with the house wrap? Did the insulation get done incorrectly? And who do you point to when there is actually a problem, right? Energy compliance can be a challenge. It would be nice if somebody else could figure out the energy compliance and your code compliance with the IECC. Affordability, obviously, many of these things end up resulting in cost overruns and issues, so affordability is a challenge. Decarbonization, again, I think that's a topic that's very important to me, and I would love to see a reduction of waste in the industry. And I mean, you see the dumpsters and dumpsters on job sites have just thrown out material. It would be great if there's an alternative that would use materials more efficiently and be installed in better ways. And lastly, this might sound like a weird challenge, but innovation. Oftentimes it can feel very risky to try new things. Builders want to use the things that they know, and I don't fault you for that in any way, right? And honestly, I think that panelized construction can maybe reduce the risk of innovation, and we'll talk about that. Let someone else take on the risk of innovating and trying new things and pushing the industry, right? So those challenges in detail. So labor shortages are impacting lead time and quality. I mean, this is data from 2023, but something like 500,000 additional workers are going to be needed on top of the normal pace of rehiring workers. And many of the workforce is approaching retirement or is already retired. So obviously we're going to need a way to improve efficiency. Materials are designed and sold independently. I talked about that a little bit, but how do you know that your insulation is going to work with your house wrap, or you've chosen the right smart vapor retarder to work with your cladding, for example, right? It might not be obvious that those things all are connected, but we'll talk about that later. Warranties are not comprehensive. Who do you point to when something goes wrong? And building science is a luxury. Not every builder has a building scientist like me on staff that can give them advice and pick layers and pick materials. So hopefully we can rely on others to do that for us and bring it into the single family home industry in a way that it typically isn't, or I wish it was more. So I think panelized construction, specifically advanced or enhanced panelized construction, is the way to do that. These are insulated and weather-tight wall, roof, and floor panels that are built in factories, starting from rough carpentry. All the studs and sheathing is installed, then insulation and air sealing occurs. Windows are installed in the factory, in some instances siding. And it goes through a different process of construction where all the engineering happens up front, three-dimensional models are built, and we'll go into this in more detail. Manufacturing occurs, bundles show up on the job site, installation, and then ultimately we blower door, right? This is a very different way of doing things, and you can imagine how having some of these things come from one manufacturer or one company could handle a lot of those issues for you, right? Here's a couple good photos of what the process looks like. And ultimately, panelized construction can provide a reliable, high-performance, weather-tight building envelope. That's really what gets delivered here, right? Is somebody else owns the performance of the building, the structure, and the envelope. You don't have to worry about the building science. You don't have to worry about framing and insulating, but you focus on finishes after and work on the things that ultimately make you money down the line. So what does this do for risk and profitability? So on average, it saves about 5 months for the builder. You can see down below, when using panels, you can effectively cut the typical construction timeline in about half, which means you can build twice as many houses in the same amount of time. These panels, because it's panelized, tends to be more flexible than modular construction. That means these designs can be customized to your designs. You can take a traditional home or a home that you would have built using on-site construction, panelize it, and then do the raising. It's much more simplified because it's coming from one manufacturer. So you have one spec, one warranty, and there is 50% less energy and reduced mold risk because you know that people are following the latest building codes, and building scientists have looked at and spec'd the materials to ensure that they're going to perform in those climate zones. And frankly, you know who to point to if there is an issue, right? So a couple other advantages. So like less time is less risk, right? There's less risk of overruns. You're not going to ultimately, frankly, I mean, overruns cost money, right? So that's good. Continuous improvement. Panelizers, it doesn't matter who it is, right? They have a factory process where they're continuously trying to improve, continuously trying to improve the product output, the quality assurance, all that kind of stuff. You can follow the latest design trends as well, right? If with Panelized, you can do many more different types of construction than you might with modular. You have a lot more flexibility, so you can stay up with the latest trends. Reduce waste, we talked about that before. When things are being cut and sized in the factory, they can be ordered to size or ordered in larger quantities and cut, so you can significantly reduce waste. It's also less theft risk because you're not piling up piles of material on your job site and risking people coming by and just taking it. And reduce injury risk, less time on ladders, less time working with equipment on the job site. The raising is done by a crane and with a trained crew, and then ultimately you have an envelope that's built, and framers aren't climbing around without fall protection. So that's good. So a couple myths, right? Sometimes people think that prefab is lower quality. I've seen some absolutely beautiful homes be built from many different panelized manufacturers that, or modular manufacturers to that end. These offsite components are built to meet strict standards and interpretation of local codes. They often go through state programs that ensure that they're meeting a higher level of quality. You'll see there's in-factory inspections, there's additional inspections from third parties, there's local inspections on the job site. So you're getting a significant amount of QA happening. You have automation, for example, you can have equipment that's cutting every stud to length, that's installing the sheeting, that's doing the nailing, that's doing the insulating. So you can be assured that, you know, these machines are being, or sorry, the lumber, for example, is being cut to tolerances that you just can't really do on a job site quickly, right? Oftentimes people think prefab reduces design flexibility. I think that's where panelized really comes into play. You can do a lot more with it than you can with some other designs, but even modular has gotten much better as time goes on. There's also a myth that offsite built homes are treated differently for mortgages and resale value. Because we're talking about industrialized construction, we're not talking about manufactured housing. They follow the same state and local building codes. We're talking about IRC construction, for example. Homes are built on top of typical foundations, and they're built to last just as much as site-built construction. In fact, I bet they would last much longer because we put a lot more effort into the envelopes. And zoning, banks, home buyers, there should be no distinction between an offsite and a stick-built home. And definitely that last myth of all prefab being the same. There's a lot of different types. There's a lot of different ways to go about it. And not every type is right for every job. So just have that in mind. So just revisiting some of those challenges. I hope you can see how having things be built in a factory and then shipped to a job site and homes being raised in a few days can help with labor shortages, schedule delays, and warranty. And we'll talk more about innovation in a little bit. I think there's some really cool case studies at the end of this that we can talk about. Okay, so how does the process work? How would you typically work with a panelizer, for example? So it starts with the drawing set, right? So when we are doing offsite construction, a lot more things need to be considered up front. So we need to know exactly where the house is going. Might be obvious, but there's a lot of things we have to plan, like where the crane goes or where bundles will be staged. And ultimately, we have to build this house digitally first. So we need to have all these details, right? So you have the site plan, foundation plan. This is an area that is incredibly important. So if we're building panels off-site and the foundation doesn't match the plan, hopefully the foundation's a little big, because if it's small, that could be a big issue. So there's a lot of coordination that goes in the process of making sure that the foundation matches what we're going to build. And oftentimes you'll see a panelizer send out somebody to do a foundation survey after the foundation has been poured. I've seen 3D scans. I've seen people just taking measurements before they'll do the final panel builds, just to make sure that this foundation coordination was done correctly. On site, if somebody builds the foundation 2 feet larger, you kind of just build the house 2 feet larger, but we don't have that luxury. We also need floor plans. This goes without saying, but we need to know what panels to build and what both interior panels and exterior panels to build. Same thing with the roof. One area to note here is penetration locations. This goes for walls, this goes for roofs. If we can coordinate the penetrations up front, that means the holes in the envelope can be planned ahead of time. And if the holes in the envelope are planned ahead of time, that means they're properly flashed, they're installed, they're ready for you to just run whatever it may be. Maybe it's a stack for a bathroom, or maybe it's an electrical outlet on the exterior. What you don't want to do is then go in and have to make modifications to something that's already insulated, air sealed, and weather tight if you can avoid it, right? So the more details we have about plumbing, electrical, HVAC up front, the better. And ultimately, obviously, we need the exterior elevations, the local dimensions, the overall dimensions, any fixtures that are going on the outside, like I said, the slopes for us to work on the structure, window, door heights. These panels are going to come with windows installed. So there's a lot of coordination that happens at this stage when we're sharing drawing sets to make sure we're all on the same page. So once a plan of, or a drawing set of that level of detail is provided, that's really when the quoting and scoping process can happen. Because without it, you don't have enough information to really start substantiating a model and figuring out what it's going to cost. So here you're seeing volumes being built. It's not every stud yet, but at least every panel or every surface is being defined. Surface areas are being figured out, and that's what ultimately determines how much something like this will cost, and all the logistics can funnel from this. What the builder focuses on, though, is different than what the panelizer will focus on. So the builder is responsible for site work, foundations, and utilities. Ultimately, the panels don't come with roofing because you have to seam them together. It can be very difficult to weave shingles and other things. So the ultimate roofing happens on the job site. Electrical, plumbing, and HVAC occurs after the panels are built. Interior finishes, and so whether it's fixtures, flooring, kitchens, that kind of stuff, that's really on the builder's side. But we kind of go through this process. Say you decide to move forward. That's when we go into design for manufacture and assembly. You can see, like, these are just 2 examples of homes. Panels can be used to build kind of funky looking houses like you see on the left, or very traditional looking homes like you see on the right. I have some good photos of a raising down the line. You can do fairly complex envelopes. They don't have to be boxes. I promise you can probably build a house that looks an awful lot like you would have built traditionally. And ultimately, we have to do what's called a virtual design and construction phase. So there is this is where we substantiate the model fully. You can see here every stud, and even on the inside, every hanger, important fasteners. The process is a back and forth process between the panelizer and the builder to make sure that everyone is happy, the structural engineers are happy, the builder is ready and says, yes, I approve, this is how I want my windows to be, this is where I'm good with the structure. And then ultimately you can go into computer aided manufacturing. These are a couple photos from one of our factory partners. You can see in the upper left a photo of a shop drawing. So every single panel that got defined in this 3D model that you see here ultimately gets its own panel drawing for it to be constructed in the factory, because we're building panel by panel. So whether it's sheathing, cutting the OSB and doing the nailing, insulating using automated equipment, installing windows and air sealing them in the factory so they're ready to go. All that stuff can happen in this phase using computer aided manufacturing and automated equipment. I think you just get a higher level of quality doing it that way. Then there's the building or the bundling and site logistics. So all these panels need to be individually bundled. You can see a photo there of a bunch of bundles of some interior walls sitting on a truck. It's a logistical challenge to figure out what the best way to ship these are. Typically, walls ship vertically, roofs ship horizontally, and interior framing ships however we can fit it on the truck. We do that so the panels are in the orientation for the pick for the crane. So you're not doing any complex maneuvering or any shifting. You're just taking it off the truck, putting it in place, getting it positioned, bolting it down, and moving on to the next one to increase efficiency on the job site. So a lot of work goes into where are we going to store these bundles? Where is the crane going to be sitting? How can we do this without disturbing the neighborhood? All that kind of stuff. But all this happens up front. The builder doesn't have to do anything. A couple more photos of some initial panels being raised, exterior wall bundle being craned into place, and you can see that RFO5. That's a roof. EW would be exterior walls, etc. Bundles being staged for this is a rather large build up in Michigan. So here you can see an envelope being put together. The home is taking shape. These raisings can go surprisingly quickly. We've built homes. I'll show you one that we built in a single day. Often it's on the order of generally days to raise a home. Could go for a little bit longer than a week if it's a very complex envelope. The panels come pre-installed with a house wrap or with the windows, all the weatherproofing. You don't have to worry about any of that. And here's what a home looks like when the raising is done. We'll still have to go in and you can see like where the floor panels are. Those will get, house wrap installed and all the weatherproofing will be completed. But ultimately, this is what gets handed off to a builder, right? Is now you can do your finishes and finish it off. But you didn't have to worry about the envelope, the structure. That's all taken care of by a panelizer. And I don't know about you, but when I look at this house, I would have, unless you know what you're looking at, when it's done, I don't think you could tell that this was panelized, right? It's not a box, it's not super simple, it's got dormers, it's got gable ends, it's got porch roofs, it does what it needs to do, right? And it's ultimately a beautiful home. So now my personal favorite part, the deep dive into building science. Honestly, at the end of this short interlude, I think you will know more about building science than probably 99% of the world. That's, and if you don't, let me know, because I think you'll understand building science in a different way. So taken from our friend Stiebrick, a building envelope is the separation between the interior and exterior of the building, which is made of control layers. And Joe Stiebrick typically describes these as air, heat, water, and vapor. You need to consider all four of these things when designing an envelope to make sure that you aren't going to have catastrophic issues. So if you design a building envelope incorrectly, you could get moisture damage. Now, it's not just if you design it wrong, it's if you build it or you maintain it or you renovate it or you insert any number of things here, you can get just disgusting issues and make a sick building, right? So I'm cheating a little bit. You can see in the upper right a picture of mold growth. That's from a flooded home, so hopefully, but just wanted to show what it could look like. And then you can see some rot that's forming in the bottom right. I think the one thing to know is that mold tends to grow when relative humidity is above 80% and the temperature is above freezing. So you can see on the right a plot of temperature and relative humidity. Generally speaking, if you keep the entire envelope below 80% relative humidity, then mold is not going to grow. If it's cold, you get a little bit more leeway and you can actually go to higher and higher relative humidities. And you can see there that depending on the type of material, if it's more sensitive to mold growth or less, the limit changes between 80 and 85%. This chart and this general guidance comes from ASHRAE 160, which is the criteria for moisture control design analysis in buildings. If you have any interest in it, it's the go-to example. And we use this type of information to model assemblies and make sure they're going to perform in different climate zones. So where does moisture come from? Why would the relative humidity be so high? I think a lot of people think of like rainwater and, if you have a roof leak or groundwater coming up through, but we don't think about interior moisture as much, right? So maybe think about people and cooking, but moisture from crawl spaces, moisture from plants. Some people humidify their houses way too much and potentially damage them. Laundry, or maybe people didn't install vents correctly, right? There's lots of areas where moisture can come from, and we need to make sure that the envelope is prepared to handle that. So, but what is moisture, right? What is moisture in the air and how is it defined? So we often talk about humidity, right? Like everybody knows, oh, it's humid or oh, dew point. But I want to give you some definitions so you're more, you see kind of the background, the science behind it. So ultimately, a definition of humidity is that it's the concentration of water vapor in the air, and it can be represented in a few ways. So the one we all kind of know is relative humidity, right? It's the ratio of how much water vapor is in the air and how much water vapor the air could hold at a given temperature. So as air gets colder, it can hold less and less humidity or less and less water vapor in the air. So whereas the absolute humidity is the mass of water over the total volume. So it doesn't change with temperature. Now, if it's getting colder and colder, at some point you'll reach the temperature at which 100% relative humidity would be reached. That's when air is cooled below the dew point. That's when airborne water vapor will condense. You'll start seeing dew. You'll see condensation on your windows, that kind of stuff. That's the dew point. So if you had, for example, a relative humidity inside the house at 70 degrees and maybe it's 50% relative humidity, you can imagine as that if that cold or if that warm humid air can hit a cold sheeting in a cold climate, that's where you could reach the dew point and get very high relative humidities in the assembly. The tip here, though, is building scientists don't really think in dew point or in humidity. They think in vapor pressure. So if you want to sound really fancy, use the vapor pressure term. Vapor pressure is the pressure which drives vapor from warm and humid to cold and dry. So it's very similar to how a temperature difference drives heat flow from hot to cold. The partial vapor pressure of water vapor is high in warm and humid, and it's low in cold and dry. And vapor will always want to move from warm and humid to cold and dry. It's very important to think about as we move forward. But yeah, if you want to sound fancy, say vapor pressure instead. So another thing to consider is that moisture transport from air versus diffusion. So diffusion is the movement of moisture through materials. It's making its way through the gypsum board, for example, or through your retarder, or through your house wrap. But more water vapor can be transported by airflow than by diffusion through materials by orders of magnitude, right? So if you haven't taken care of air leakage, I mean, you should still think about vapor because you can't ignore diffusion and the diffusion of vapor through materials, but you really have to solve for air tightness first, which is why I advocate for airtight buildings and and proper ventilation. But how do we slow down vapor? Let's say we took care of gross air leaks and holes in our envelope. We have to stop this vapor from getting the cold sheathing and from causing issues. So vapor retarders are what are used to slow down the diffusion through the building envelope. And there's different classes of vapor retarders, all the way from vapor impermeable, which would be, or sometimes called a vapor barrier. Nothing is really a vapor barrier. A little bit of moisture can always get through. It just gets through slowly. That's 0.1 perm or less. And then you kind of move up through into vapor semi-impermeable, vapor semi-permeable, and vapor permeable or permeable. That would be if you're over 10 perms. Now, that's I'm using the term perm a lot, right? So what is a perm, right? Perm defines how easily vapor molecules will diffuse through a material. The higher the perms, the easier the moisture transport through that material. So think about it as how open a valve is or something like that. Like the more open the valve, the more perms, the more moisture can move through that. And different materials will naturally have different perm values, right? So drywall with paint can be as low as 3 perms if you're using a vapor retarding paint, up to about 35 perms. Whereas if you're using exterior foams, that can be quite low. Like an XPS can be less than 1 perm, which is a vapor retarder on the exterior of a home. So but what really matters and how you pick layers in an assembly is all about the climate. It's where you are in the country and whether or not it's commonly cold. Is it a mixed humid where there's a lot of heating and cooling going on? Is it grossly humid all the time, like in southern Florida, for example? And as you are in the northern part of the climate, moisture tends to move from the inside to the outside. It's hot and humid inside in the wintertime, and it's cold and dry outside. So diffusion is going to try to move through the wall and get to the exterior, whereas it's the exact opposite in Florida. So it may not make sense to use the same exact assemblies everywhere, right? And it's something to think about. So I want to go through an example real quick that might illustrate this fact for you. So here's a wall assembly. Pardon my horrendous PowerPoint art. But hopefully you understand the cross section. I'm an engineer, not an architect. Vinyl siding, a weather-resistant barrier, OSB, fiberglass, and gypsum board on the inside, right? Very, very simple. Now let's consider what the temperature profile looks across this wall and what the vapor pressure might be. So let's say we're in Boston, it's 70 degrees Fahrenheit on the inside, it's freezing outside. Let's say it's warm, that means it's warm and humid on the inside, it means 50% relative humidity, and it's cold and dry on the outside. Moisture, in this case, remember moisture wants to move from warm and humid to cold and dry. Moisture is going to diffuse from outside to inside, from warm and humid to cold and dry. If the sheathing is cold enough, which we don't have any exterior insulation, we don't have anything, it could be cold enough to hit the dew point and actually cause condensation or moisture collecting in that area. So if you don't have a vapor retarder, this is what's going to happen. And I guarantee you're going to have a lot of wetting during the wintertime in Boston if you didn't have a vapor retarder. So we should install a vapor retarder there to limit or prevent the amount of moisture collection that can get to the sheathing. The vapor diffusion is effectively blocked. Again, it's not perfect, but it effectively will block the moisture. Now this looks great. You're like, hey, solve the problem. Let's put poly everywhere. There's no issue. But what happens during the summer now that you've added a vapor retarder on the backside of the gypsum? Now it's 90 degrees outside, it's 70 degrees inside. Now the direction of moisture transport has changed. So during the summer, the moisture is going to want to go from outside to inside, and now it can be trapped behind the poly, behind the vapor retarder. It'll drip down, condense on the backside of the gypsum, drip down and rot out your sill, and it can just be awful, right? This is where something called smart vapor retarders can really come into play and can completely avoid this problem. So smart vapor retarder, there's lots of different kinds of them. I'm not going to, for this presentation, I won't dig into the different types and manufacturers of them. But the idea of how they work is that during low humidity situations, they remain moisture tight. So in wintertime, basically it's relatively dry, say 30, 40% interior RH. They'll stay tight and prevent that diffusion that I was talking about and stopping moisture from getting to the sheathing. Whereas during the summertime, when it's generally more humid inside, let's say 50, 60%, maybe even higher, the permeability of these materials can increase, and that lets the moisture that's getting behind the gypsum out, and your HVAC can take care of it. So it's materials like these that are being considered and used in panelized systems to make sure that there's not going to be mold, rot, and other issues. I also want to briefly talk about the moisture benefit of exterior insulation, because this is not the most intuitive thing in the world. Adding vapor open exterior insulation increases the sheathing temperature. You can see I kind of drew a line there of what the temperature would do. So now the sheathing is not at freezing. It's somewhere in between 32 and 70, depending on the ratio of interior to exterior insulation. And at some point now, you won't hit the dew point at the sheathing anymore. So you end up, by adding insulation to the exterior, resulting in a situation where you can't cause condensation and moisture buildup in that situation. I will caution you, though, that when you're adding vapor closed exterior insulation, you have to consider what that's going to do to the vapor drive and where moisture could accumulate. So you have to make sure that you're adding enough exterior insulation such that you will not avoid, or you will avoid hitting the dew point. Otherwise, you could just be trapping moisture and cause an issue, right? And let's see, Brett, do you have a comment or a question there?
Well, no, and I'm glad you brought that up. So I threw a link in the chat, and for those listening or not seeing the chat in the future, we did a session with Oak Ridge National Laboratory's Building Science Advisor tool. So that you can build your wall assembly in that model and your climate, and you can figure out how much exterior insulation you need on the outside. Now, unfortunately, I don't think that tool has smart vapor barriers built in yet, so maybe you all need to work with them to fix that. But just wanted to put that plug out there. There is these tools now you can kind of see what's going to help with that. So thanks for bringing that up.
Yeah, no, that's a great point. I think Oak Ridge has been doing some really, really great work there. So ultimately, here's an exploded view of what an assembly could look like. And I've highlighted the different layers that contribute to those different things we need to consider, right? So when we're considering air management, air sealing is being done with dense pack insulation, with the interior vapor retarder and the house wrap. Heat management, pretty classic. It's going to be your insulation materials, right? So that would be in between the studs as well as exterior insulation if you had it. Water management is fairly obvious. Your cladding, maybe your exterior insulation. If you're not using your exterior insulation as your WRB, maybe an additional WRB layer underneath. The one that's very interesting, though, is vapor management. So I have included the exterior insulation in that diagram there because of what I talked about with the dew point and trying to keep the sheathing temperature up, right? So always ask yourself when you're thinking about what layers you're going to spec and how, what are the consequences of my decision when it comes to the perm value of this wall? And do I want it to be vapor open? Do I want it to be vapor closed? And ultimately, you generally want to block vapor from the highest source of moisture. So that's just to put it simply. I think modular and prefab construction have a big advantage in this instance of doing air sealing, of adding weatherproofing, kind of stuff. So on the left, you can see a carefully designed and installed window buck, where the tape detail is happening in the factory, where things are clean and it just goes on beautifully. You're not trying to stick tapes to wet and dirty surfaces out in the field, right? It can all happen in a factory. This, like I mentioned, the substrates are dry, so installing caulks and tapes and other rolled products can really improve the adhesion. And I think it's really neat that you actually in Panelized, you have access to the panel or module edges that can improve your air sealing details, right? So there you're seeing people apply a tape that's going to get folded over the edge of a panel. That actually means when two panels come together and they get gasketed, you're continuing the air barrier from one panel to another. And actually, you might even be able to see that that smart vapor retarder is actually both glued and taped. So each individual bay is sealed off. So if you lost one stud bay, you wouldn't compromise the entire panel, and then the entire exterior is also taped. Not everybody does those details, right? But it's something that I like to see. So just a summary, because I know it's a lot of stuff, right? And actually, sorry, Brett, do you want to jump in? Oh, you're on mute.
Sorry, I thought you maybe this is in your summary too, so feel free to summarize if it is or add this into your
Yeah.
summary. Well, let me just give you two questions, and then you can add it hopefully into your summary. So the first question is, what about the concern of vapor barrier behind paper-faced chipboard? And then the next question was, are the panels available with plywood rather than the product OSB you show in your assembly diagram? So
Yeah,
I'll add that
that's
and
a
you
good
can throw
question.
that into your answer.
Yeah, um, so first with the gypsum boards, I wouldn't be concerned personally about a paper-faced gypsum being used. If it's a high moisture area, there are gypsum manufacturers provide gypsum boards that are designed for high moisture locations. And actually, if I go back to maybe this slide, I don't know if you guys can see my mouse, but the vapor retarder being behind the material is totally fine. And in fact, it's actually going to prevent condensation coming this way from hitting the gypsum board in the first place, right? So I think gypsum board traditionally has a very high perm value. I wouldn't be worried about it. It'll dry out even if it did get wet. I'd be much more worried about the framing and other things in that area. The other question about plywood. So actually, let me see if I have a photo. I don't want to go too far back. The From what I typically see panelized and modular factories doing is using OSB primarily for its stability and maintaining its shape. I've heard horror stories of plywood warping and not being able to lay flat for the nailers to be able to either do the automated cutting or the nailing using the bridges that are used. So typically you'll see people use OSB. I don't want to say that no one would use plywood, right? But maybe we can talk offline about that option if it made sense for a different project. I hope I'm getting to that question. But so just very brief, we'll focus on the blue bolded stuff. Remember to consider air, water, vapor, and heat. Vapor drive is always from the hot and humid side to the cold and dry, and mold grows in conditions greater than 80% relative humidity and above freezing temperatures. So if you can avoid that in your envelope, you will not have a problem. You will not get mold growth because it is not conducive to mold. I didn't mention it completely, but avoid a vapor sandwich. You really want to avoid two vapor closed layers that could trap moisture in between them. Because if moisture does get in there, and it will eventually, maybe it doesn't happen next year, but it might happen 50 years from now. If you can't dry, that's when you have big issues. Think like a raindrop is a great just saying to have while you're working and flashing materials. You always want to avoid reverse laps if you can, scoops, that kind of thing. Don't forget about your interior finish when thinking about vapor retarders. For example, you could spend a lot of time detailing your smart vapor retarder, and then if you end up putting vinyl wallpaper on the inside of that, it probably didn't matter. I would be much more worried about having a vinyl wallpaper over gypsum than I would using smart vapor retarders that are really designed for this. And offsite construction provides an opportunity to improve performance. So whether it's adapted air sealing measurements or techniques, vapor management details that you wouldn't typically do, being able to apply tapes and other things that apply better in dry conditions, I think it really gives an opportunity to elevate performance and overcome that myth that offsite construction is not good, right? Or is lower quality, I should say. Okay, so some of the work that I've been doing for the past 7 years or so. Back to this slide. If a panelizer is going to sell you an envelope, that means they own the whole assembly and they need to ensure predictable performance. These assemblies are going to be built tens, hundreds, thousands, tens of thousands of times. You want to make sure that it's done correctly, right? You don't want to just, it's not responsible for the company and it's not fair to a builder to not do your due diligence, right? So the way that this is done to ensure it starts out in modeling, right? So extensive mold growth analysis is performed for lots of different assembly types and different climates, lots of different materials, whether it's fiberglass or cellulose, XPS, wood fiber board. All these things are considered, and we end up making plots and charts for different locations to prove that assemblies that are designed will work in the various climates that they're being sold in, right? But you don't want to just focus on modeling, right? I'm not going to name different modeling softwares, but they've gotten very good. You can usually trust the output as long as the person that did it knows what they're doing, picked the right materials and the correct conditions. But what's even better is to build houses and check it, right? So what we did was we embedded sensors in the first homes that we built to measure key performance indicators. So we wanted to validate the design analyses, enable accurate pre-built performance estimates, right? So like make sure that what we're doing matches the modeling and inform future design improvements. You can always get better. You might find something needs to be improved. And ultimately, we're measuring relative humidity, energy use, weather data, air quality, temperature. That's all being uploaded to the cloud, and then custom Python data processing software does all the work. You can see some photos of sensors being installed. These are commercially available sensors. We didn't design anything in particular. The trickiest part was running 5-volt power to all these things and to have it all be code compliant and safe. The data is transferred over a wireless network, and then the power is delivered wired, particularly because I can't leave, these sensors are going to live and die in these panels. I can't leave batteries and have fire risks and those things. We can see walls and roofs being installed in the factory. We also focus on transportation. So what happens if we build a panel, we insulate it in the factory, and then it's got to go down the road, and shaker table is a perfect way to test that, right? Like these are loads that typically you wouldn't worry about with on-site construction, but the trip from the factory to the job site is the most likely where something would happen, right? So we have to test those things. So we do large-scale shaker table testing where we'll shake panels following ISTA 3B standards, if I remember correctly. It's about 750 miles of road transport. We see on the right is a photo of the first panel I ever unbundled. And I was so happy to see that insulation hadn't settled, because that would not be a fun day if you have to fix that. We're achieving that by dense packing fiberglass insulation to sufficient densities that it can self-support and it overcomes the road transport loads. And you get the benefit of a higher R value, something like R25 for a 2x6 wall like that. Also, you have to figure out how to do siding in the factory. It's not an obvious thing how to do this, and you're kind of installing siding backwards, where at least with vinyl you might install the trim first and then slide in the siding and set all the appropriate gaps. And how do you make sure that the seams between the panels are going to look good and you would never know it was a panelized home, right? These are all types of things that different types of R&D that go into this. Also, insulation has to happen in the factory, all the tuning to make sure that the densities are correct, that the materials work with the different types of equipment. This is some insulation equipment that's from Europe, but used in New Hampshire. You can see a roof panel with some really nice, well-insulated fiberglass there that I think came out fantastically. Our first home build, panels took about 1 week to build, and the raising happened in about 3 days. This is a small ADU in Mystic, Connecticut. That 3 days took a long time. This is the first time we were doing it with our system. There's a lot of learnings. Today, that house looks like this. I think it came out absolutely beautifully. You can see it on magazine covers and in books. It's a very well publicized ADU, and we're incredibly proud of how it came out. And actually, the homeowners are also incredibly proud. They love their house. They love their house so much that they got a vanity license plate that matches their house. So, the name of their house. I just thought that was really, really great. It shows you how well of a job we did. So, second home build was 7 days. There's a 1,400 square foot house in New Hampshire. That included some finishes in the factory. And then we raised this home in 1 day and achieved an envelope air tightness of 0.26 ACH50. It's one of the lowest ACH50s I've seen. And there's nothing special about it, right? That is the type of air tightness you can achieve with a system that's well detailed, with the layers defined well, with the tolerances of prefab construction using automated equipment, right? It's very difficult to achieve this level of air tightness with traditional on-site construction. You'd probably be chasing down leaks for weeks to get a number like that. Looks like this today. It's currently a rental home in New Hampshire. It was zero energy rated, EPA Indoor Plus, Energy Star. This is an instance where the envelopes are designed to help you get to net zero, but because there are so many other things that are considered as part of net zero ready, right? It's not just what the R value and the air tightness is, right? There's what are the appliances, what's the HVAC, what's the surface area of the roof, that kind of stuff. Typically that stuff relies, the builder is responsible for that, but we provide as much information as we possibly can, or other panelizers would certainly help out. But honestly, I think it, performance-wise, it came out really well. And the sensors that we embedded in these homes, we've developed dashboards to monitor them. And you can see we look at things like, we have 3D models that we can see where every sensor is. We're tracking mold growth models, temperature and relative humidity, indoor air quality, energy usage, all that kind of stuff. I realize I apologize for having all those technical difficulties in the front. We might go a little bit over, but I'll try my best to wrap up shortly. So some key findings from the remote monitoring. So there's been no observed excessive humidity or sustained mold growth calculated in any of the homes that we've instrumented. Both the homes that you saw are net zero capable based on their measured energy usage. The first home, the homeowner wasn't interested in getting net zero, getting the official net zero ready label. But we've proven, even with the roof, a monoslope roof facing the wrong direction, facing north, the home is so efficient that you could actually have enough energy generated to be net zero if you're not officially net zero ready, if you catch my meaning. I also thought it was really cool that the second home heating energy usage matched the HERS rating to within 1.3%, meaning what we're modeling and what we're building are perfectly aligned. The homes are performing the way that we expected. And the sensors have allowed us to successfully diagnose multiple HVAC issues remotely. So for example, there was a really bad cold snap in 2023 where no one was living in the home at the time, but we were we were conditioning it to make sure that we had good data for the sensors, right? And all of a sudden the home just got cold and we're like, this is a good envelope. Why is this happening? But because we're monitoring all the loads in the house, we could actually see that as it got colder, the supplemental heating didn't activate and the heat pump was actually ramping down. So it just hadn't been commissioned correctly. And we were able to tell this from Northborough, Massachusetts, and looked at the data and was like, hey, what's going on? We call up the owner of the home and say, hey, you have a commission problem, you have an HVAC problem, please fix it. You can imagine this could be useful down the line for any number of things, right? Yeah, and just a little bit more info there. And then also there was a couple issues with HVAC being commissioned appropriately for ventilation, where when you build these super airtight houses, you have to make sure that your ventilation is set to the appropriate levels and that you're considering, whether it's your ERV or your intake air needs to be appropriately set up. And we were able to tell that there were issues in both the homes and ultimately identify that remotely and fix it. So it's a much healthier, safe location for people to live. So ultimately, all the houses that we've built so far that we've been monitoring are, it's cliche, but they've got an A+ in all the things that we've been checking out. And we're very confident moving forward that the panels are designed appropriately. Okay, so I want to get to the Q&A because I think that could be very, very interesting. The learning objectives are here at the end of the slides. I think you all have a copy. I think Brett sent it out. So please just know that I went through and I summarized everything for you. So if you fell asleep for the entire presentation, you can come to the end of the slides and see kind of the key takeaways from the learning objectives. Make sure you get all your credit that you deserve for attending the class. But with that, my name's Will. My contact information is here. If you have any questions, you want to reach out, you have questions about offsite, you just want to connect, I'd be happy to chat. Just send me an email. That's probably the best way to get a hold of me. And that I'm going to say that officially ends the continuing education portion of this session. Brett gave me the thumbs up, so I think we're good there. I'm going to just show one more slide if you'll allow. I couldn't talk about it during the actual presentation, but the system that I've been working on for now almost 7 years is called One Precision Assemblies. There's a QR code on the screen. You can go to the website, certainty.com/OPA. If you're interested in using panelized construction, want to build single-family homes, townhomes, duplexes, ADUs, please take a look. I'm not going to say any more than that. This isn't a sales pitch. I just want you to know we exist, and it's not just theoretical. This is a launched product, and you can work with us and build houses today. So, okay, thank you.
All right. Well, thank you, Will. Yeah, we're going to get into some questions. We're going to hang out for a little while for those of you who do want to hang out. But if you have to go, good news, before we get into those questions, that yes, this session is being recorded and we're going to record all the Q&A too. So if you're like, I gotta go, come on back, see if your question was answered, and rewatch this, share it with a friend, share it with a colleague. You can wait a couple of days and check on our YouTube channel, or you can go there right now, click subscribe, get an instant update when it is available. And real quick, as those questions are still coming in, for those of you watching this in the future, but not right now on demand, take your quiz with an 80% passing rate, and you will receive your continuing ed. For those of you here live today, and as long as you've been here for the entire CU approved hour, you should be good to go. As long as you have the correct name, written into your Zoom and email, you will receive an automatic certificate from certs@gutenbergcerts.com in the next couple of days. Check your spam to receive that. And as always, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, our over 400 members. We're celebrating our 25th year anniversary this year, trying to get to 500 members. So if you haven't become a member yet, help us get there, as well as our top tier sponsors, such as Build Equinox with demand controlled ventilation, Rheem with decarbonized water heater, and Tamarack ventilation for better air quality in our homes. So, Will, let's get into questions right now about process. There were a lot of questions about process. I'm going to try to merge a couple of them together, but one came over that was pretty concise. And so the question is, how do you address the different inspection processes and code amendments that vary from state to state or even municipality?
Yeah.
For instance, Washington requires the Labor and Industrials Department to inspect closed panels or modulars in factories. Other states have different processes. So if the code and inspection requirements are not consistent between location, it impacts the efficiency of the prefab process for national or regional prefab companies because it needs to be adapted to local jurisdictions. So how have you dealt with this?
Yeah. So it's a very good question, and they're definitely hitting on one of the pain points, right? So we have been working with each state that we build, and you saw that we've primarily been focusing on the Northeast. We're expanding into the Southeast next. I think there may be some announcements happening very soon if they haven't already come out. But generally speaking, we work with the local municipalities and the state programs, right? So we're happy to get on the phone and talk to the local inspectors with you, to talk to the AHJs, to talk them through the process. It's not something that is foreign to us. We're happy to explain the process, right? But one area where we've been trying to push forward recently is working directly with the ICC for evaluation reports. So like right now, our system is approved by the ICC. So you could theoretically one day, I'm hoping, be able to say, hey, look, this is a product. It meets the IRC according to the ICC. Here's the report. And the AHJ should say, sounds good. You can install it. We're going to see how that goes, though.
Yeah. So, there's another specific question about what's the approval process, permit, and inspection. So I guess that's maybe the first answer to that is it depends on each jurisdiction, correct? I mean, but is there, in general, it sounds like if you've got the IECC stamp process set up, you give that to the local jurisdiction?
Yeah, that would be one place to start. And if they would accept that, then you're good. It really depends on the state because closed panels are considered differently depending on what state you're talking to, right? So you may have to go through their modular program, or you may just be working with the AHJ. But our team is very familiar with working with the different states that we're a part of, right? So it's really on us to talk with them, and we're happy to do that with you or do that ourselves to to
Yeah.
help smooth that over, right?
Now, the whole point of above code programs like Energy Star or DO Zero Energy Ready or Low Energy Rating Index HERS ratings or the green building programs is meant to it might, typically when you make the commitments to those standards, you then don't succumb to the issue of code changes because you're already building above code. Now, I know I think when people are asking you about codes, they're talking about all sorts of other issues, not just as related to the energy code, but
Yeah.
does by committing your product and having it, is it kind of zero energy ready in the sense then you don't have to kind of worry about these changing and improving energy codes?
It's also a very good question. You guys are hitting on some tricky ones. So we do focus on the latest versions of the codes. What's
Okay.
particularly like we're looking at the 2024 IECC requirements, for example,
Right.
or whatever it may be, right? And typically, like the net zero program is going to reference the latest version of the IECC code, for
Right.
example.
Right.
Where it gets tricky is in some of those stretch code areas, like where you have a HERS requirement or whatever. But
Yeah.
it's really something that we have to work together with the builder. We can provide as much information as we can, and we really own the performance and the air tightness, the envelope, the R values, that kind of stuff.
Hmm.
But if you want to go for example, I'm not going to, I can't guarantee you'll hit net zero, for example, because you may not use the right HVAC, right? For example, I don't know. Does that, you know what I mean?
Absolutely.
Yeah.
Yeah. And I do want to talk to you about HVAC in a second, but staying on the wall assembly, Passive House seems to perhaps be an answer to the question of like, what do we do when potentially Energy Star is gone? Improved energy rating indexes is also another answer floating around out there in green building programs. But let's stick with Passive House. What barriers are there if someone wants to commission a Passive House, for working with prefab homes?
Yeah. So it depends on the who you're working with, right?
Mm.
And what panelizer you want to work with and what company.
Mm.
For us right now, our highest performing wall, for example, would be an R25 plus
Yeah.
5.
Yeah.
And our roof would be an R60. So it's
Hmm.
really meant to hit net zero, not necessarily passive. However, I'll,
Right.
I'll be very honest that, I mean, I'm in R&D. If enough people came to us and said, hey, we're really interested in doing passive builds in the Northeast, I can advocate for that and see what we
Yeah.
can do, right? But for now, it's very much more a net zero focus. Now,
Yeah.
hopefully that's still a thing, but you know,
Yeah, yeah, yeah. And so, thinking about part of Passive House and even net zero is air leakage, and I may have missed that part. But how is it that you're guaranteeing that reduced air leakage in the wall
yeah.
assembly?
So typically we'll say that a less than one ACH 50 is very easily achievable.
Okay.
The second home that we built, that one had pretty extraordinary air tightness. That was 0.26 ACH 50 when we were
Mm.
done. But the way that we get that is one is the detailing of those layers in the assemblies. You may remember the photo that I showed of the smart vapor recharger being glued in place, for example, and every stud
Mm.
bay individually isolated. And there's both gaskets and tape that happens at every panel seam. So even if you had a tape failure, you still have a double bulb gasket that stops air leakage and vice versa, right? So there's a lot of work goes in up front so that we're not chasing down leaks on the job site.
Um, and on the wall assembly, sticking with that, is there any concern with replacing the interior gypsum board with pine paneling as long as the rest of the layers are included and installed as you've shown?
That's a good question. I don't see why pine would be an issue. You could
Yeah.
probably do a wood interior.
Yeah.
It's nice to know some, like if you give us a heads up, because we could always run a woofy model or something and make sure that it's not going to be an issue, right? Like happy to do
Oh,
that.
yeah. Well, if you're doing Woofy models, there's half the answer to the passive house question. So
Yeah.
I'll just note that for
So
everybody.
all the
Uh,
all the assemblies have undergone extensive woofy modeling. I didn't want to talk brands and stuff during the actual.
yeah, I mean you can't not get to passive house without Woofy, or at least
Yeah. So
one
all
of
of
the
it's
versions.
done at least primarily at the the major city level and all the different
Yeah.
locations that we're a part of.
Yeah.
So
Yeah, no, that's great to hear. So okay, let's switch gears real quick a little bit into HVAC and mechanical. So there's a specific question about, the use of and I had to actually ask the person what this was because I'm like, what is that? So EVAPs or water evaporation systems being used in junction with your products. But let's, take a step back and again just look at what kind of mechanical systems, for air quality, moisture management, and conditioning are
yeah,
being, suggested. And then I'll add to that, are you adding in EVAPs in certain parts of the country?
yeah. So generally speaking, we recommend electrification. You're
Yeah.
you're getting a high performance envelope. It's very airtight. Whether it's an ERV or an HRV is appropriate for your location. Now that doesn't mean that builders aren't going to want to use whether it's natural gas or whatever it may be to heat the homes and
Mm.
but frankly we should be using heat pumps and ERVs, HRVs, right? That's what I would recommend. Um, I don't I don't know. We'd have to talk about the specific project, where it is, that kind of stuff, to make sure that the HVAC that you're talking about in particular would make sense. I'm not as familiar, right? Um, just, but generally speaking, electrification is what I would recommend, and not humidifying the house to 70 and 80% and growing tropical plants. Don't do that. Otherwise, I think you're okay.
Um, uh, so you had shown or you had mentioned being highly accurate to utility bills in one of your case studies
Mhm.
with the rating, which is phenomenal because a lot of people question the accuracy of these ratings and kind of garbage in, garbage out. However, then you went on to say that people didn't live there, and so I have to ask.
Oh no, yeah, yeah, okay.
Did I mishear that? Because I know technically if the rating should have performed far better if someone wasn't living there, but can you clarify that?
Yeah, so I should be very clear that
Yeah.
that was the heating load estimates for that. So it's not including plug load and stuff like that. So it would be the lighting, the
Oh,
heating, the conditioning, that kind of stuff was very accurate. But it's not accounting for people running space heaters or that kind of stuff, right?
so you tell me if I'm wrong here.
Yeah,
You actually broke down, you had sensors on the electric box or whatever to break down each device, and those
yeah,
were netting you what the HERS rating was saying, correct? Is that
exactly. You got it.
okay?
Yeah, each circuit is modeled
I missed that
separately.
part
Yep.
entirely. So
No, I
that
probably didn't say it, to be honest. That's fair.
Yeah, yeah. So now are you also collecting real utility data in your case studies to see the accuracy there? Because I suspect that's really where people are going to say, well, what are people actually spending when they live there?
So we don't, oh, that's a really good question. So I don't think we're looking directly at their utility bills. To your point, it depends a lot on regionality, how much you're spending for power, for example, right? It's going to cost different in Connecticut than in New Hampshire where these houses are.
Sure, on the cost. I mean,
But
cost is, I don't even
we
want to go there,
do,
right? But the
yeah, but
usage, right? We can get that.
yeah.
Yeah.
Oh, but we can also,
Yeah.
so not only do we have the sensors on the individual circuits, but also
Uh,
the the main panel or the
uh,
overall service coming into the home as well. I
yeah.
could ask the homeowners for those bills, but I don't need them because I've already
Yeah.
got it in the
Yeah.
system.
Yeah. So let's talk about pest management. There's a very specific question about pest management, but maybe we can broaden it to a larger conversation.
Yep.
Obviously, air sealing, huge pest management strategy right out the gate. Their specific question is there ever an issue with rodents eating the sensor wires? And then what are the lifespan on the sensors and wiring in the wall? When do they need to be replaced? And then
Yep.
maybe you can add any other context of just general pest management strategy. So,
Yep. So um, first, I'll say that our monitoring program is going to be for 3 years, right?
mhm.
So I haven't put these particular sensors in a house for longer than that. We're coming up on the end of that period soon, I think. So I'm not too worried about it, right? About a sensor drifting over 20 years, for example. I'd have to look at the specific sensors and what they claim for accuracy over time.
Mm.
Um, it's mostly for us to do the modeling comparison and make sure that we're okay. As
Yeah.
far as pests are concerned, so that is a big consideration. So for example, in a few locations, obviously we have to do like termite detailing and do the flashing to keep, I think it's like bent metal or something like that to keep termites away. Or we use a fiberglass exterior insulation. It's actually a product called RKL that we get from our broader company, Saint-Gobain, in Finland. And we detail that with bug screen and everything to keep rodents and bugs out of the bottom of that, right? So, but generally, I mean, we're building a very high performing envelope that's all taped, everything's sealed up. I mean, at least so far, I haven't heard any issues, but
Yeah.
so.
Um, so you had mentioned at the beginning a little bit about embodied carbon briefly. I know, theoretically speaking, by minimizing waste in a factory controlled setting, you're already eliminating some of that embodied carbon compared to on-site construction. But this specific question is looking more at sort of life cycle analysis. So it's a two-part question, partially looking at um, end of life disassembly.
Mhm.
So, I don't know if that's 100 years or 1,000 years from now, but what are you thinking there?
Yeah.
And then are you incorporating bio-based materials that might be both healthier, American made, hopefully American grown, and lower carbon?
Yeah. So as far as lifetime goes, it's a
Yeah,
good question.
yeah,
Design for disassembly is a topic broadly for Certainteed and for Saint-Gobain, right? It's an
yeah.
important area of research and things. Obviously, you are, we're still working with traditional materials at this point, but maybe down the line, I can't speak too much, but you might see things in the future. And at least speaking for Certainteed and Saint-Gobain, we are certainly considering alternative materials, particularly for insulations, right? We do have a relationship with Timber HP, and we also have a cellulose company as well called ICC, but not ICC, the ICC. So certainly considering those things, it's not off the table. What's nice about the fiberglass that we use a product called Optima. We can hit R25 with the densities that we're achieving to resist road settling. So
Mhm.
basically, we're dense packing in order to achieve longevity down the road, and we also get a benefit of hitting R25 with that product. So
Mhm.
it's kind of a win-win there.
Yeah. Another question that came in is looking at alternatives to the panels as far as wood goes. So this particular question was about light gauge metal, but any other alternative materials being explored for prefab?
Not as far as not there yet, I'll say. We're primarily
Yeah.
focusing on the kind of single family home, duplex, townhomes, that kind of thing. So you wouldn't see a lot of light gauge metal or anything like that in that situation.
Well, yeah, and so I'm glad you mentioned because I was going to bring in my other question is, those who are doing multifamily housing, is this an opportunity for them at all? But maybe not yet.
So um I I bet if you talk to our sales team, they
Yeah.
would like to chat,
Yeah.
but we're working on it. Let's put it that way.
Okay. Um, Uh, so another question came in just about how you are selecting the particular products you are selecting.
Mhm.
And whether that has, the homeowner or the builder, the architect plays a role in that, and how does that process play out, down to the product level?
Yeah. So when it comes to the envelope materials,
Hmm.
that is spec'd by us, right?
Okay.
We have done the research and the design, and primarily they're coming from Certainteed or the broader Saint-Gobain portfolio. So we know that they work together, we can warranty them, that kind of stuff, right? Where we can talk though is in finishes and particularly if you're going to use like reservoir claddings, we may want to change some layers in the assembly or something like that. If you're thinking like a brick veneer or a stucco or something like that, that's where things
Hmm.
get a little bit trickier. But generally speaking, and I'm not saying I don't trust other people's recommendations for materials, but we know what works, and we have building scientists to show it, right? So that's
Yeah.
what I would say.
And then a specific question, and I don't know if you want to share your screen again for that, but they said, did I see roof panels with vapor permeable fiberglass cavity infill? Would that be the only roof insulation, or is impermeable also used?
So the roof panels are insulated with fiberglass,
Mhm.
but they are, for the Northeast climate, they are vented. So there is
Mhm.
basically a 2x3 sleeper that goes on top of the I joist, and it creates a
Mhm.
vent space. So it's a
Mhm.
vented cathedral roof
Mhm.
assembly, which is
Yeah.
pretty interesting.
Yeah.
Certainty would not use like a closed cell foam, for example.
Yeah.
It's not our product, and honestly, I don't. Depending on what foam you're using, I wouldn't support it from a sustainability perspective either. So
Sure. Um, as far as manufacturing location, of course, LEED gives out points when you spec products within 100 miles of the site. Of course, people want to buy local.
mhm.
They want to keep things local. And I understand, right, when it comes to this kind of product, you really can't start to go too far. It becomes cost impediment. So the question kind of here is, where are your factories currently at and where are they going to be?
Okay, so I can talk about where we build today. I don't know if I can divulge where they
Yeah,
will
I mean,
be.
if you
So
don't want
that's, yeah.
to, whatever you want to say.
I don't think that's public information, but
Okay.
um, we're building currently in New Hampshire and in Pennsylvania.
Okay.
So like I said, we've been
Pennsylvania,
focusing on the Northeast, right? Um,
Pennsylvania, capital modular of the world, right?
Now, but we are expanding. I think our director Dennis Michaud may have posted on LinkedIn that we're expanding to the southeast. You can infer from there, but I'm not going to go into more
So,
detail from there.
so if you're in, so it sounds like you've got the coast covered. So how far from Pennsylvania, is that cover the Midwest then in general from the Pennsylvania location?
So we can go out to around Michigan is probably the farthest that we would go,
Yeah,
right?
you mentioned a project up in Michigan, so yeah.
Yeah.
Um, Great. Um, well, I don't see any other questions here for now. Will, do you want to quick share that last slide you had? I forgot to add it with your contact information.
Yeah, sure. Let
Um,
me
but yeah, if I guess you can share that, and then just for anyone who can't see anything, maybe let us know where people can go to reach out to you or find out more.
yeah, so can you see the final
There it is.
slide? Okay, so
Perfect. Yeah.
yeah, so the best way probably to get a hold of me is via email. It's william.lentley@saintcobain.com. You could also find me on, you can add me on LinkedIn or something, send me a message. I'll get back to you there too. Those are probably the two best places. You can also reach out to us on the Certainteed website, certainteed.com/OPA, and you can find, there's a contact us form there. You'll get a hold of some individuals. And if you end up working with us, we might end up chatting about your project. So hopefully we see where things go. But that's
Yeah.
me. And if anybody has questions, honestly, please just reach out. I'd be happy to chat, whether it's about building science or offsite or anything. Very open to it. So
Yeah. All right. Well, I really appreciate you and Certainty and Saint Gobain for having you out and giving the time. So thank you so much for joining us, and thank you all for attending. And we'll catch you all same time, same place next week. So bye all. Take care.
bye, everybody. Thanks for having me.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.